Good evening, everyone. Welcome to this live session. As you know, your exam is scheduled very soon. If you have specific questions that you think you can, need answers to, you can interact with me now. Or if you have other questions related to concrete in general, I'd be happy to answer those in the session. I think I'll just pick up first the questions in the Google response sheet. There are only 2 questions there. I'm not sure if the people who have asked these questions have joined. Yeah, one is Nikhil Ramesh Rathod. Nikhil, I don't see him here. Second one is from Tarak Nath, who has joined here. Okay. Am I audible?
Yes, sir.
Yeah, good. Okay. So I'll just answer the questions from the Google sheet first. There's a question from Tarak Nath. How to distinguish alkali silica reaction from lime leaching? One of the indications of alkali silica reaction is white patches on the surface, which is similar to lime leaching. Which way can it be differentiated? Okay, so now Tarak Nath, with respect to lime leaching, right? You have water from within the concrete, which comes out with the dissolved lime to the surface. This lime essentially converts to calcium carbonate on exposure to atmosphere. So lime leaching need not be accompanied by any cracking in concrete. In alkali silica reaction, you will see the irregular crack pattern, which we call as map cracking, right? You will not see the same in lime leaching. If you have joints in your concrete, sometimes you might see that the lime is leaching out of these joints, but you will not have cracking associated with leaching.
Yeah. Good evening, Professor. Thanks for answering.
Yeah.
Sometimes it happens that practically we see a little bit cracks, maybe the shrinkage cracks or maybe other stress-induced cracks in the structure. And from that also, sometimes the lime leaching may happen.
I understand. But what happens is in lime leaching, you'll see a sort of a smeared out appearance of the white patch. It will not be exactly on the crack itself. It will be smearing out. But in ASR, your white patches that form are exactly in the cracks. And with exposure to atmospheric carbon dioxide, these white patches will turn black in ASR. Over a long term, you might see that these white patches start turning black. You'll not see the same happening in lime leaching. It will always be white because it's basically calcium carbonate.
Got it. Thank you. Thank you, sir.
Welcome.
Sir.
Yeah.
Sometimes concrete cubes observed lime leachings.
Concrete cubes, you're saying lime leaching. Okay. So that's probably the cubes that are stored directly in water, right?
Yes, sir. Yes, sir.
Yeah, see, again, when you store directly in plain water, because water has a pH of 7, the lime and the alkalis which are inside the concrete are trying to leach out to the water. Okay, and that can happen sometimes.
Sometimes.
Yeah, so my suggestion is when you store it underwater, put some calcium hydroxide into the water tank.
Calcium?
Hydroxide. Lime, basically. Put some calcium hydroxide into the water tank and stir it up. So the water becomes high pH and you'll not have that much leaching happening from the concrete specimen into the surrounding tank.
Okay, sir. How much doses?
Yeah, you'll see that beyond a point, the calcium hydroxide will not dissolve because it's got only limited solubility. So you add to the point where you don't see it dissolving. All of it will just go and settle to the bottom. That's all.
Okay. Approx 0.1%, 0.2% of the water.
No, add about 1%. I think that should be okay. Not more than 1%. Yeah. If you have 100 ml of water, add 1 gram of calcium hydroxide.
Okay, sir. Thank you, sir.
Good evening, sir. Sir, in uniaxial compression case, the first crack we have observed in the uniaxial compression case, it occurs in the plane in which the tensile strength is very less
Yeah,
for the concrete.
right.
So and then we report this strength as the compressive strength of the cube.
Yeah. No, see, when you're compressing the cube, right,
Yes, sir.
there is going to be a lateral strain
Yes, sir.
because the concrete is not restrained in this direction. When you compress the cube this way, it's going to start bulging out in this direction. And when you do that, the lateral bulging out is going to induce a tensile strain, which will exceed the tensile capacity of the concrete. That's when the cracking will appear. So in the case of a uniaxial compression test, we are essentially doing a test that fails the concrete in tension and not in actual compression. There's no crushing. You don't actually see the concrete basically crumble to a powder. That would be a crushing strength or a compressive strength. But here we are compressing it. We are not restraining it in the other direction that it expands or bulges out. And that's why the crack forms. So that's why when I have indicated in hardened concrete lesson, we talk about restraining it in biaxial compression. In that case, we are increasing the load carrying capacity because it is not allowed to bulge out.
Yes, sir. So also in the normal concrete, in which the cracks that appears in the ITZ.
Yeah.
So if the crack is appearing at the ITZ, it means it has exceeded the strength of ITZ. So
No, I mean, yeah, okay, not necessary, but yeah, ITZ is the link which is causing the failure to propagate. Correct.
So we can say that this compressive strength of concrete of normal compressive strength of normal concrete can be the strength of the ITZ.
Well, yeah, it's limited by the strength of the ITZ. So if you remember the discussion in that chapter, the cracks initiate in the ITZ and then propagate into the matrix.
Yes, sir.
So the strength of the concrete is not directly the strength of the ITZ, but the ITZ is contributing to the strength of the concrete or contributing to the failure of the concrete. So we can't say that the bond ITZ is equal to the compressive strength. No, not necessarily. No.
Sir, and the design mix proportioning of IS 10262.
Yeah.
So it doesn't follow the particle packing concept.
Well, not necessarily. If you look at the aggregate gradations, that are defined by any mixed design standard, if you look at IS 383, which is the aggregate standard,
yes, sir.
That aggregate standard basically sets the guidelines for what is the required gradation for fine and coarse aggregate and also a combined aggregate gradation. So in general, that basically is still referring to some mode of packing of the aggregate combination together, right? So that is something that it's already inbuilt, but the only thing is it is not inbuilt to look at the modern techniques, which also look at the finer fillers. The previous particle packing or gradations were based on the 0.45 power rule, right?
Yes, sir.
Discussed in the chapter.
Anderson model.
Yeah.
So and in the design mix concept of this IS 10262, we have the zone of aggregates, zone 1, zone 2, zone 3,
Correct.
zone 4.
Correct.
So in India, we have different types of for different reasons, we are having different types of mineralogical composition for the aggregates.
Correct.
So how do we take them as like we are in northern regions? So which zone? What will be the effect of that mineralogical composition of aggregate?
No, see, based on the mineralogical composition, when you are crushing the material, if you are obtaining your fine aggregate from crushed stone, for instance, depending upon the type of stone, the crushing will produce varying degrees of finenesses, right? It will produce a very different gradation. It may produce a finer level of aggregate as compared to a coarser aggregate and so on. So this is all basically controlled by the mineralogical composition, right? Now, mineralogical composition is dependent on obviously the origin of the rock itself. And if it's a metamorphic rock, it will fail with foliations and things like that. So all of those things will have a say on the ultimate gradation that you get. But that doesn't mean that everywhere you have to go only with zone 1 or zone 2. You have to work with whatever you've got. And when you work with whatever you've got, you need to make the right adjustments in terms of your aggregate combinations, the cementitious content, water cement ratio, super plasticizer, and so on.
And sir, like for durability of concrete, like we are having sulfate attack and carbonation attack.
Yeah.
We are generally using different types of super plasticide, you are using super plasticizer, we are using different types of cement. Can we use some like we are using galvanization for steel? Can we use any painting or painted
Coating.
surfaces coatings in concrete also?
Yeah, definitely. There are construction chemical companies also sell coatings, which can be actually additional measures to protect your concrete against chemical attack. Right? So apart from making the concrete itself more durable, less permeable, and so on, you can additionally have a protective coating on top. There are epoxy coatings available for concrete also, which can help reduce the extent of carbonation of concrete. There are coatings which are waterproofing coatings, which will reduce the penetration of water into the concrete. So all of that can be done.
Okay, sir. Thank you, sir.
Yeah.
Good evening, sir.
Good evening.
Sir, very basic doubt, sir. If you can please explain the procedure or the flow chart of a mixed design, sir. Any mixed design, because what should be the time taken after we mix the aggregate and cement and fine sand? How much time it should be there in the machines for some? And then when is the time to add these mixtures, especially if we are going for say carbon fibers or any sort of fiber, because for the evenly distribution part, if I add water, then it will become a lump or something. So is there a pattern as per your experience? What should be the procedure, sir, actually?
Yeah, see, again, this will depend on the type of mixer that you have, right? In most cases, depending upon the speed and the shear that the mixer is capable of doing, you may want to try out different combinations. Ultimate aim is obviously to get a homogeneous mixture of the concrete. If you're using fibers, for instance, the mixing process should ensure that these fibers get properly dispersed. If you're using silica fume, right, which is a very fine particulate condensed material, so it has to be broken down into particles to really get dispersed into the volume of the concrete. So there, mixing is very essential to ensure that this happens. So what you need to do is create a condition in your mixing which ensures a very homogeneous mix is obtained. And for that, depending on the type of mixer that you have and the capacity and the potential of each mixer, it will vary. Now, in terms of your strategy to put in admixtures, the strategy is obviously to first put the dry materials, get them intimately mixed. In fact, during the period of putting the dry materials in, you can also put your fibers, right? But sometimes certain fibers are glued and they can only be put after the water is there because the glue dissolves in water and then releases the fibers. So all of that has to be as per the requirement of the individual materials. In terms of adding your chemical admixtures, generally, you have to add a little bit of your water first to the cement and then only the super plasticizer. Generally, in most cases with lignosulfonates and naphthalene sulfonates, that's what works best. But in terms of polycarboxylates, people directly add it into the water and also dispense it in the concrete. So you have to obviously ensure that your mixing system is capable of delivering the material in whichever way you want. Sometimes admixtures may have some incompatibilities with each other, in which case you don't want to mix the admixtures together, but as long as it is getting mixed in the concrete, it's okay. So as I said, this will depend a lot on the situation that you have and ultimately come down to the extent of confidence that you have in your mixing system.
Thank you, sir.
So just I'll quickly go to the spreadsheet. There's one more question. I think Nikhil Rathod has joined us. So there's a question, is there any alternative method for doing accelerated carbonation test without the carbonation chamber? If no, then how to design and fabricate a low-cost carbonation chamber? Now, the alternative to doing an accelerated carbonation test without a chamber is to do a natural carbonation test. You expose your concrete to the external environment. Problem is, there the percentage of CO2 in the atmosphere, as you all know, is only about 0.04 Even in a highly polluted environment, it will be not more than 0.07%. So in such a case, the speed with which carbonation will occur in the concrete is going to be extremely slow. You'll see a few millimeters in a couple of years. That's why we try to do the accelerated carbonation test. Now, an accelerated carbonation test chamber, it's not all that difficult, although getting the right controls can be a little tricky. What you need to do is ensure that you are able to put in a supply of carbon dioxide into your chamber. The chamber has to be controlled with respect to its temperature and humidity. That is not very difficult. Many environmental chambers are commercially available. It can be manufactured on your own also. You can convert an existing oven also into a chamber like this, where you control the temperature and humidity by the right kind of fixtures, right? And then you can insert the CO2 gas and ensure that you are able to maintain a flow that maintains a certain concentration of the CO2 inside the chamber. That can be done. So what we set up at IIT Madras for our carbonation chambers, we also did not buy any commercially available chambers. We wrote the specs and we actually got it fabricated specifically for us. And of course, the company that made it for us then later became very popular and they started selling everywhere in the country. So the one which we've got fabricated is all from experiments and experience. Okay. So yeah, alternative to doing accelerated is to do a natural carbonation, but that takes forever. Okay. Nila Kanmani has posted questions from the discussion forum and from YouTube. There is Jafar who's asking how to achieve same packing density with different aggregate proportion combinations. Please elaborate. Okay, powders of different sizes or particulate materials of different sizes, when you mix them in different proportions, they're going to pack to varying degrees, right? You have three different materials of different particle size distributions. They need not have only one unique combination in which they'll maximize your packing. There could be more than one possible solution to that problem. That's why the same aggregate materials, three different aggregate materials in different proportions may end up giving you the same packing density. That's what really happens, right? You saw in the examples I provided in class also that when you are trying to design self-compacting concrete, one way to look at it is to actually look at minimizing the voids in the system by maximizing packing density. And we see that the maximum packing density is obtained with different aggregate combinations. Sometimes you have to choose very high amount of fine aggregate, sometimes very high amount of coarse aggregate. At various levels, you can actually pack the materials well enough to get minimum voids in your system. Another question posted here is from Pankaj Sharma from YouTube. Why do we take 54% more in calculating dry volume of concrete? Is 54% an empirical value? I'm not too sure what this is in reference to. 54% in calculating dry volume. I'm not able to get where this question is from or what this question is intended to mean. If Pankaj, if you can elaborate on that question and post it again in YouTube, I'll be able to help you. In the meantime, if there are other questions, I request people here on this forum to open up and ask them directly. You can. I see there's a large number of participants today. I have not seen this level of interaction before. Okay, there's one question which has been posted. Happy Deepavali. Okay, good. Happy Deepavali to you. First question is, why more workability of fly ash based concrete compared to silica fume and material based concrete? Of course, there you have to go back to the structure of the fly ash. We have seen that in the mineral admixtures section, that fly ash particles typically are spherical. Silica fume is also spherical, but it's much, much finer, right? So it increases water demand. So at the same level of water, fly ash particles will be able to provide this, what we call as a ball bearing effect that increases the workability of the system, right? Same thing, if you have, instead of crushed angular aggregate, if you use the riverbed aggregate, which is rounded, you will get much better workability at the same water content. The second part of the question is workability test of hybrid fiber reinforced concrete is only done compaction factor test. Is it correct? No. Okay. Maybe you want to mean generally applied to fiber reinforced concrete as compaction factor the only test. No, not necessarily. There is actually a slump test defined for fiber reinforced concrete also, where what is done is you put the slump cone in an inverted fashion, fill it up with your fiber reinforced concrete. Okay. Then it is not kept on the ground, it is kept elevated. Then you put in your vibrator into the slump cone. So what that vibrator does is it allows the concrete and the slump cone to flow out, and you take the total time for the concrete to flow out of the slump cone on vibration. That's one way to check the workability of fiber reinforced concrete. If you use regular test method like regular slump test, the fiber reinforced concrete may have almost zero slump. You may not be able to get that. VB test is a very useful test. You can do VB test. Compaction factor, it's cumbersome. It's not that great. VB test is nice. You can use VB test, because in VB test, you are basically having a conical shape of the concrete and you vibrate it and it becomes a perfect cylindrical shape. And that basically is helping you assess the time taken for that to happen, and more workable the concrete, the quicker that happens.
Sir, good evening, sir.
Good evening.
Sir, I am asking a basic question about shrinkage cracking, sir.
Okay.
What is the order of shrinkage? Autogenous plastic like that. What is the order, sir? Dry cracking.
Okay. What is the order implying? How much strain is there in these cracks? How much strain is there in these shrinkages? Is it? That's what you're asking.
Sir.
What is the level of the strain you're saying?
Okay.
No. What are you asking?
So I want to clarify about the order of cracking, sir. Which is first comes, autogenous or plastic?
Oh,
cracking?
which comes first? Okay.
Yeah.
Sure. So plastic shrinkage cracking comes very early, right? It comes within the first few hours of the concrete. Plastic shrinkage cracking is the one which comes earliest. Autogenous shrinkage is a problem primarily with very low water to cement ratio concretes. The extent of the autogenous shrinkage can be sometimes very high, but the cracking due to autogenous shrinkage may not appear so early because concrete is still under curing at that particular time. If you stop curing of the concrete, and if the water inside starts drying out because of autogenous shrinkage, any restraint to the concrete will create cracking. So that may happen probably within the first month or two, not more than that. Autogenous will come at that time. If there's any cracking, mostly cracking due to autogenous shrinkage will happen at that interval of time. Drying shrinkage, we are seeing very long term. Drying shrinkage cracking will happen over a period of several months, because the extent of drying shrinkage slowly keeps on increasing. And at one point, the extent of your restraint provided may be high enough to cause sufficient stress to initiate cracking. As far as thermal shrinkage is concerned, or thermal contraction is concerned, again, for large masses which increase in temperature and start cooling down or contracting, in such cases, you can get thermal cracking. And this can happen within the first few weeks. Okay, so plastic shrinkage, autogenous shrinkage and thermal cracking in the first few weeks. And then long term, you have drying shrinkage.
Thank you, sir.
Yeah.
I am Apavari from Padai, sir. My name is.
Okay.
Okay, thank you, sir. Thank you.
Thank you.
Sir, Rakesh here.
Yeah.
Sir, we all know mineral admixture is just like pliers, GGBS is very useful of durability point of view.
Yeah.
But in the bullet train projects right now, Mumbai, Ahmedabad, not using pliers, or many of the government projects also not using pliers or GDBS.
Yeah.
What is the main reason behind of this?
Good question. We've been trying to talk to these people, asking them to use mineral additives, because I've been even going on saying that OPC should be technically banned from using in any structure, because we are answerable to the environment, and by using directly OPC, we are contributing too much CO2. So as far as possible, any project, we have to replace cement with fly ash or slag. We can always design the concrete to achieve any level of strength, except when, of course, we are going for very high volume replacement mixes, but that's not the case. In infrastructure, we only go for 20, 25% or maximum 35% of replacement. So yeah, we've been talking to them. Most of these projects, which are infrastructure related with government clients, the structural designers call the shots in such cases. They are not that keen on looking at new material developments. Unfortunately, that's been the personal experience. and they are not really allowing innovations in material technology that easily into the project. So it takes a lot of talking, dissemination. Yeah, so we've been discussing, we want more and more infrastructure users or infrastructure companies to continue to use. In fact, with L&T, we have got a very good relationship. They have actually implemented suggestions from us in terms of using slag and fly ash in several projects, in fact. So yeah, we are trying our best to disseminate information and try to get more people to use it.
So another question was,
Yeah.
I observe in 7 days cubes, sometimes aggregators are broken and 20 days obviously broken, but 7 days sometimes is not broken, sometimes it's broken.
Okay.
Understand my question, sir?
You mean aggregate is broken?
Means cube where we cubes are crushing.
When you do the crushing of cubes, you see the aggregates getting broken.
Yes, yes.
Yeah,
So which ways in generally some of the my seniors told me in 7 days generally not crushing the aggregate. It's good, or sometimes it's crushing the aggregate, but it's not good.
Yeah, see, it depends on your aggregate type. See, sometimes you may have some weak aggregates also, which cannot take the stress at 7 days. Usually, you don't see aggregate cracking at 7 days unless your concrete is very high strength. So if you're going to use concrete of strength 50 plus megapascals at 7 days itself, you may actually see the aggregate cracking also. In high strength concrete, the paste and the interface are so strong that the cracks prefer to go through the aggregate, because that's the shortest path for the crack to go, right? In low strength concrete, the aggregates are not going to crack. The crack goes around. So that's why you see cracking the ITZ a lot more in normal strength concrete. So yeah, it may happen. It's not a guarantee that it will happen all the time, but depends on the strength of your concrete overall and the type of aggregate you've used in the system.
Sir, in SEM, when we do the analysis of concrete specimens, sir, we generally get the image in black and white only, sir.
Yeah.
And due to the experience only, after putting so much only, we are able to identify which is CSH or the particle signal. Is there any technology or development coming up wherein different colors can be like visualized?
No, see, again, in electron microscopy, you can't really visualize colors. You can only do that in optical. Because only in optical microscopy, light has a tendency to interact with your matter and then get refracted or reflected. And light has a variable spectrum of wavelengths. Electrons have a single wavelength. So you're not going to be able to make out colors with respect to that. So electrons interact with the concrete, and the colors you make out are with respect to your differences in the gray levels. You only make out different gray levels of colors.
So that's the reason. Using some polymer, sir.
No, that is again polymer using. You can only do it in optical microscopy. In electron microscopy, your polymer will turn out to be black mostly because it's low density.
Only because I used some polymer, so it was spherical in nature. So because of that image only, I had to keep on identifying what are the spherical images and which.
Correct. You have to go with the morphology, the size and shape, and also the texture of the things that you see under the microscope. But color you can't change in electron microscope. You can suggest that.
You can suggest that in optical microscope, I'll have a better, clear understanding about this.
No. Because optical microscopy has a limited resolution. You can't go to the scales that you can go with electron microscope. Because again, please remember, electrons have a much smaller wavelength as compared to light. So because of which you're able to resolve much better features.
Sir.
Yeah.
Thank you, sir.
Yeah. I'll come to the chat box. There are some questions there from KPC Rao. In the slide, it was told that dolomite is having high strength. Hence, it has less effect on shrinkage and creep. The strength graph of aggregate siltstone has least elastic modulus, and it should have great effect on shrinkage and creep. But siltstone has maximum effect of shrinkage and not creep. graph shows quartzite is having maximum creep. No, so again, please remember the type of aggregate will affect shrinkage and creep primarily because of its contribution to the stiffness of the concrete. Okay, so the more stiffer the aggregate, right, the lesser will be the creep. Okay, but in terms of shrinkage, you also have the well, again, aggregates should also resist shrinkage to a larger extent. Again, see, I don't know if I can explain this entire data because this is from a particular experience. I think the data you're referring to is showing some data that we've got from South Africa. Okay. So, yeah, I mean, essentially, you should think about the fact that aggregates which are stiffer lead to lower shrinkage and lower creep. But more so, it will have an effect on creep. For shrinkage, what will have an effect is the amount of the aggregate. The more the aggregate, the lesser the shrinkage. And of course, the lesser the creep also. Shivang is asking, I wanted to ask, how can we know about quality of flexible pavement by eye judgment and rough manner? I have no clue. I mean, to me, a flexible pavement, as long as it looks like it's smooth and good to ride on, that's how it's good. But I'm not really an expert on flexible pavement, so I can't really answer this question. Sunil, okay. SCM abbreviation. SCM is supplementary cementitious material. Supplementary cementitious material. Sunil has said that SEM image is obtained by scattering electrons, so no colors. Yeah, exactly. Correct. It's not scattering visible light. Colors will come only when visible light gets scattered. Avi Prajapati is saying, if high-grade concrete is a concern, we generally intend to use mineral admixture. My question is, what kind of mineral admixture is good for precast system? Here we have mineral admixture with calcium oxide 30 to 40 and silica 40 to 45. I'm not sure. You're talking about the use of mineral admixtures in high-grade concretes. We can definitely design concrete with high grades which have mineral admixtures. It's not really a problem. We have to choose appropriately the water cement ratio and ensure that we are fulfilling workability demands by using superplasticizer. Of course, when you use very large content of fly ash, it has a detrimental effect on the early age strength. It takes a long time, long period of curing is required. But with slag, even 50% replacement, there is no real problem typically. Sai Charan is asked. Yeah, go ahead, Davi.
This is Avinash Prajapati, sir.
Yeah.
Actually, we have two type of mineral admixture, like alcofine and microsilica.
Yeah.
Alcofine, we are having silica content up to 40 to 45%, and calcium oxide about 30 to 40%.
Correct.
Other in microsilica, we have a silica content from more than 85%.
85%. Yeah.
The question was like as we compare both, we got cracks from alcofines. When we use alcofines, in the initial stage, we got a finer cracks, hair cracks in precast systems. So we tried with a mineral admixture of that microsilica. So it got minimized. It's because of heat interaction or else, sir?
No. See, when did these cracks appear? Were they early cracks?
Yes, early cracks.
Yeah, early cracks probably are because of plastic shrinkage. So alcofine essentially is ultra fine slag, right?
Exactly.
Ultra-fine slag, whereas microsilica obviously silica fume. Now, both of them can lead to a higher propensity for early age shrinkage. We've discussed this in the class also, that early age plastic shrinkage will increase whenever you replace cement with microfine materials, because water does not find it easy to move and the surface zone dries even before setting happens. That's why shrinkage cracking happens. So your experience with the two materials should not necessarily be very different. As long as you take precautions, either of these materials is okay, in my opinion.
Okay, sir.
Yeah. I think we just need to take precautions at the early stage to avoid the cracking. And that we have discussed how to take precautions against plastic shrinkage.
Okay, sir.
Sai Charan is asking, why don't we use interlocking bricks, which is prepared by using coconut fiber and brick? Is it give good strength to building? No, fibers and bricks are generally used to help in reducing the extent of cracking due to drying and other effects, right? Ultimately, the strength of the brick will be the same as regular brick. Coconut fiber is not going to increase the strength tremendously. Yeah, I mean, I'm not sure why this question is related to concrete technology, but yeah, in general, you can use interlocking bricks. Nothing wrong with that. Coconut fibers, of course, you need to get some experience in using it and trying to determine what it does to your strength of the brick, but it should not generally affect the strength. Atar Hussain is asking, sometimes 28 days strength is below 100% strength, whereas 7 days was more than 100% same sample and cast by same technician curing. What is the reason behind this? Okay, that reason has to do with the way that the sample has been prepared. It is there is no reason why 28 days strength should be lower than 7 days strength. Other thing could be that your curing beyond 7 days has been affected somehow. If you're getting results like this, there's a problem. Usually you don't see a strength loss from 7 to 28 days. That will usually not happen at all. In very long term, there could be other reasons why strength loss is happening, which is more internal with respect to the chemical alterations that are happening in the concrete system. But from 7 to 28 days, you should not see a reduction in the strength. Shrish has asked, in particle packing concept modeling by Emma, if you use crushed stone aggregate and riverbed aggregate of same size for two different mixes, will mixes be affected due to type of aggregate? So yeah, I presume you're saying that crushed stone is angular, riverbed is rounded. So in particle packing modeling, which only considers particle size, will you see any difference? Yes, you will definitely see a difference. So particle packing model only looks at size. It does not look at shape. So unless you actually do an experiment to determine what happens at the particle packing suggested by Emma, you will not be able to figure out. So your workability especially, you cannot just base it on achieving the best particle packing. You also have to look at particle shape. That will also have an effect on all those aspects. Okay, definitely. Your mixes will be affected if you have angular versus rounded aggregate, even if you use the same particle size distribution.
Sir, for this question, we in this particle packing, we are reducing the void for a minimum. For both crushed aggregate and riverbed aggregate, will it this software will reduce it for the same level, or
no, what I'm saying is the software only takes an input of your particle size.
Yes,
right?
sir.
Particle size distribution. It does not take any input of your shape.
Yes, sir.
Right. So it will only give you the same kind of model for crushed stone aggregate or riverbed aggregate as long as they have the same particle size distribution. But when you make concrete with both of these, you will definitely see an effect. You will definitely see that the crushed stone aggregate concrete ends up giving you a poorer workability but better strength as compared to riverbed aggregate. Yeah.
So we may get a result in that both proportions are same as we are having only that size as a major aspect for this modeling.
Correct. So it's not going to take care of shape, but generally this is not really a problem, right? Because if you are at a particular job site, you're only going to be getting aggregate from one single source.
Yes, sir.
You're not going to get crushed stone one day, riverbed the other day. So this is only a theoretical question what you're asking, but yes, you're right. It does not take into account the particle shape.
Yes, sir. Thank you, sir.
Yeah. Sunil is asking how sensor embedded in concrete can help monitoring hydration or strength. Smart Geotech is producing sensors. It is very costly. Yeah, but these sensors have to be used when you really need to produce data from within the concrete. So sometimes what happens is the concrete that you store inside cubes and store in ideal conditions does not give you an exact picture of what's happening in the actual structure. In such cases, if it is required to monitor the strength gain directly in the structure, you may want to put these sensors. So Geotech has sensors for temperature, for instance. In mass concrete structures, it's very important to understand the temperature evolution in the structure to ensure how to decide on when to remove formwork and things like that, because you want to avoid temperature differentials which can lead to cracking and so on. Yes, so definitely what you have to look at is whether the sensor is required from the perspective of meeting the job specifications and what kind of information you're getting and how actively you're using this information. There's no point in simply collecting information. If you're going to be actively using it, then definitely it's a useful thing to use sensors. Yes, sensors are expensive, no doubt. But if you're going to be measuring temperature, you don't need a Geotech sensor. You can also use thermocouple wires, which are connected to a simple temperature data logger. All that can be made for a cost of less than about 30,000-40,000, and you can keep buying thermocouple wire whenever you want. It's not a big deal.
Professor Taraknath here.
Yeah.
This is regarding the high strength concrete. Most of the cases, high strength concrete, I mean, concrete which is actually maybe beyond M80 or M90 like that. So those concretes are mostly specified for high-rise buildings. Now, one more key parameter for high-rise building is that modulus of elasticity.
Correct.
Now, when the modulus of elasticity is defined, then probably the design, the grade of concrete is actually governed by that parameter. I mean, modulus of elasticity.
Exactly.
My experience, I worked in Lafarge, and my experience is that for high strength concrete, most of the cases we don't get that empirical formula. I mean, the strength is not similar. I mean, modulus of elasticity is not similar to that 5,000 root over FCK.
Correct.
It comes little less than that. So
yes,
when someone is specifying that M80 grade concrete with certain modulus of elasticity, maybe 42 GPa, probably the design will be M90 or M95. In that case, the aggregate will be the weakest part in the concrete, because the aggregate will crush earlier than the paste get crushed. Now, what should be the strategy to accommodate that sort of specification during the mixed design?
Yeah, I mean, see, with aggregate, you really don't have too much of a choice, because aggregates are dependent on the local geology. So, instance, if you're making a building in Mumbai, you're obviously going to be using the basalt aggregate that's available there. You can't go too far with aggregate, because you need to fine-tune your mixed design, keeping in mind that this is the aggregate that you have. You can't really take that into account when doing mixed design. But the question you have raised is important, because in such high-rise buildings, the strength is not that critical. The modulus of elasticity is critical. And if you can produce concrete with the required target strength, but with higher modulus of elasticity, that's going to be quite useful. There is actually some research going on around the world to do this, to see whether we can avoid the use of extremely high strength to produce the high modulus required for high-rise buildings. So there, some work has been done in using carbon nanofibers inside concrete. And some results have shown that those have a much greater impact on the elastic modulus rather than the strength. So if you really require strength-wise, if you need only M60, but because of the modulus of elasticity, you have to raise it to M90, right? So that difference of 30 MPa is obviously going to cost your concrete a lot. You're going to be wasting a lot of money trying to make it M90 instead of M60, just because you need to meet the modulus requirement. So in such cases, you have to probably look for alternative solutions, but there is no commercial solution yet. It's still in research. But as far as the tall buildings are concerned, these days, all structures or concretes that need to be specified for tall buildings have to follow the tall building code, in which case the modulus has to be tested separately. So you cannot use the 5,000 square root of FCK relationship anymore. The modulus has to be established by testing.
Yes, sir. Exactly. We are also specifying the same thing for one of our building projects to test regularly. And just one more input from my side, sir. One of your lecture videos. This is actually the topics in hardened concrete. They started with E is equal to 5 root over FCK. So probably you need a correction for that.
No. I think I have put E in GPa.
Okay.
Yeah.
Okay.
E in GPA, FCK and MPA. That's why I put 5 square root of FCK. Yeah.
Okay, I got it.
Yeah,
Got it.
I understand. That can create some confusion if I've not written the units there.
Right. Yeah. Thanks, Professor, for answering.
Sir, now with respect to the mixed design part, sir,
Yeah.
we are doing all these tests in the concrete testing in a lab, sir. And there, invariably, generally, we are always focusing on the strength of the concrete.
Right.
But whereas the most important part is shrinkage and creep also.
Right.
Actually, when we cast the thing or we construct the building, sir, at that time we start all these cracks and shrinkages and everything, sir.
Right.
So, do you suggest that we prepare a 1 meter by some slab also and do the checking of shrinkage and creep also, sir?
No, see, shrinkage and creep are time-dependent phenomena. They'll take a long time to get established. So if you have time to do your concrete mix design and you have set a very clear understanding of what level of shrinkage and creep you can expect and accept in the structure, in such a case, you should use that time to actually do the mix design properly. So yes, you're right. We should do additional measurements of creep and shrinkage, but you don't have to make a wall section for that. There are test methods to measure creep and shrinkage potential of concrete mixes. But mind you, it requires at least 6 months of data to establish these quantities.
So in generally, sir, nowadays, if we are like everywhere we are running around and we want fast construction and everything, sir. So can we say that if we are going for a high strength concrete or a M30 or M40 concrete, and can say that if I do this kind of mix design, I will not have shrinkage and creep? Is there any possibility of that, sir?
No, if I do this kind of mix design, what?
Like if I follow the procedure properly, I do all the procedure rightly, sir. Like the mix design proper, and in my compressive strength, I get M30, what is desired for me. Can I conclude saying that it will not have shrinkage and creep in future?
No, you can't conclude like that. You definitely will have shrinkage and creep.
Sir.
Whether the shrinkage and creep is acceptable or not is something that you need to see by using that value in design. See, IS 456 also accounts for shrinkage and creep in the structural design, because those are time-dependent deformations. So one has to look for that in design. You can't assume that just because you've done the design correctly, you'll not have shrinkage and creep. Any concrete will shrink and creep. Okay, even high-strength concrete will shrink and creep, but at a much lower rate than low-strength concrete.
Sir.
So yeah, it'll always be there, shrinkage and creep.
Sir, generally I observe some complaints from as a RMC, we concrete casted slab. So generally initial cracks, shrinkage cracks are observed, but in the same where manual casting by volume matching, initially cracks are generating.
Okay.
After some time, contract is said your RMC cracks is more than our manual casting.
Yeah.
So what is the main reason behind this?
Yeah. Okay. See, again, when you're doing manual casting, right? When you have site mixing.
Yes.
We generally don't pay too much attention to water. There's a lot of water used. Okay. So in such cases, what happens after you lay your, let's say, a slab and finish the top surface, a lot of water bleeds up to the top surface. And because of bleeding, it is giving a nice coating on the surface, and any drying that happens of that concrete only dries off this water. But in RMC, the water content is controlled. Optimal water is used. So when you're actually laying your slab, if any drying of the top surface happens, it is directly drying out the water in the concrete. That's why you get plastic shrinkage crack. In normal site mix concrete where water is not controlled, you will not get plastic shrinkage. But the problem is your surface water to cement ratio in such concrete will be so high that your concrete itself will be very poor in site mix concrete. So what you have to do essentially is when you're using RMC, pay attention during the early stages. In the early stages, what you need to do is ensure that if plastic shrinkage cracking is appearing, you need to use a wooden float to try and rub off on these cracks. We have done this actively on some projects within IIT Madras also, and it works beautifully. You don't really even need to go for expensive solutions like fibers or shrinkage reducers and so on. Either covering the surface and preventing evaporation, or simply using a wooden float and rubbing the crack if it appears, because it will appear within the first 2-3 hours. just have enough workmen on site to rub the cracks, it will disappear. If you are able to control, if you are vigilant during the first 3-4 hours before setting, you'll not have a plastic shrinkage cracking problem. But yes, RMC, water is more controlled, optimal, right? Because of which you have the propensity to have these shrinkage cracks. And RMC usually will have fly ash also. And that will reduce the speed of setting. So it will increase the setting time. So because of that, there's a propensity for forming cracks. So you have to be careful, that's it. But otherwise, the quality of concrete you get from RMC is definitely much, much better as what you get from on-site.
Okay. The second thing was, sir, as what I'm reading of drying sinkage, water is more than drying sinkage is more chances.
Yeah.
So in manual casting, is chances of more drying sinkage?
Absolutely. Much more drying shrinkage will happen. Plastic shrinkage is different than drying shrinkage. Somebody asked earlier, no, at what is the time period? Plastic shrinkage happens in the first few hours. Drying shrinkage, we are talking about a long term.
How much after 1 year? Sir?
Yeah, maybe 6 months to 1 year. And yeah,
Okay.
you'll definitely see a lot more problems. And more than drying shrinkage, using more water will lead to poorer durability of concrete. Don't forget that. That's the most important message.
Okay. Thank you, sir.
Yeah. Some questions in the chat box. One person has asked, Chidananda has asked, BIS has released code for accelerated carbonation test. Can we expect a code on RCPT? I think RCPT code is already written as one of the sections of this IS 516. So it will come out soon, I think. Naveed has asked, in geopolymer concrete, when we increase alkali content, we will get higher strength, but same time, temperature higher than 80 degrees Celsius is required. How will we get high strength at atmospheric conditions at 30 to 35? So that depends on the type of aluminosilicate precursor that you're using. For instance, if you're going to be using fly ash, right, you have to have higher temperature during curing. But if you use type C fly ash, you may not require that very high temperature. A regular fly ash is type F, siliceous fly ash, where you need to provide high temperature curing because only then the okay, I forgot the name. The aluminosilicate dissolution happens and the polymer starts forming. But when you want to do at room temperature or 30 to 35 degrees Celsius, you can do it with a mixture of slag and fly ash. So slag as an activated alkali activated system, slag is very good. In fact, slag reacts almost immediately when you use it in an alkali activated system. In fact, within 1 hour, you lose all workability. So when you mix fly ash and slag, you get some benefits of the early strength of the slag, but also you get the long-term slow dissolution of the fly ash and contribution to the geopolymer structure. So if you want to do it at room temperature or 30 to 35 degrees Celsius, slag fly ash mixtures are quite good. Okay, Chidananda is asking, when can we expect revised IS 456? What about durability conditions and revised exposure classes? Handbook on concrete durability from ICI is available. Annexure A in that book suggests revisions for concrete durability. Yeah, so all this is being incorporated in durability, in the durability provisions in IS 456. This is still under discussion. We've done all this contribution to IS 456 already. I'm hoping in the near future, within the next year, I think we should be able to release this. In chemical admixture, J. Vignesh is asking, accelerators such as type 2 and type 3 at low dosages, seem accelerators act as retarders. Is this really acting as retarder, or to act as accelerator, does it require minimum quantity? Yeah, you're right. See, sometimes the retardation effect can be seen, but what I wanted to bring to your attention is that you need to have a certain dosage beyond which it will really act as an accelerator. See, it may act as a retarder also at very low dosage, but that's not the primary thing we want to see. We want to increase dosage at least to a level where we start seeing the acceleration. Nikhil has asked, could you explain the difference between prescriptive and performance-based standards? Which is better? I'm hoping you would have learned this from the lesson, but again, just to repeat myself here, prescriptive means you are placing requirements on your cement type, cement content, water to cement ratio, and so on and so forth, assuming that you will achieve durability by specifying these things. In performance-based standards, you are essentially talking about your obtaining the required performance to meet the requirement of a particular location. For instance, when you talk about marine concrete, you talk about chloride diffusion. When you're talking about inland concrete, you talk about carbonation resistance. So all those are to be measured in the concrete instead of placing requirements on the type of materials and water binder ratio. Okay, so that's performance-based standards. Definitely performance-based standards are the way to go in the future because we want to use more and more of mineral admixtures. In the current scenario, somebody had earlier raised this point, in infrastructure projects, only OPC is being used. That's because people are comfortable with it. They don't really bother about performance, right? So once you start stipulating performance, then you start looking towards these other mineral additives. Athar Hussain is asking, what is the optimum air content for cryogenic concrete? I have no idea. Cryogenic concrete is used for extremely low temperature applications. Air content is only required if you have freezing and thawing cycles. So if your concrete is always going to be in cryogenic condition, I don't even think air is required. Okay. So depends on the application. Shree's asking, explain the effect of curing at 70 degrees Celsius or more on DEF. Yeah, again, this is there in our lecture discussions. If you increase curing temperature to more than 70, your ettringite at the early stages is not stable. It goes into the CSH in the form of sulfate and aluminate and so on. Later on in the long term, when moisture is available, the sulfates and aluminates come together within the microstructure of the CSH and form ettringite. And whenever ettringite formation happens in hardened concrete, it leads to expansive stresses being generated and cracking. Madana Gowda is asking, many researchers mentioned reduction in strength of concrete, more than 10% replacement of cement by fly ash, silica fume, material and mineral mixture. I'm not sure which researchers mentioned reduction in strength of concrete when there's more than 10% replacement. Not necessary. It depends on your mix design and depends on what age you are measuring your strength. So there's no reason why your strength should be lower for concretes with mineral admixtures. Afia is asking, in geopolymer concrete, how to decide whether we need to go for steam curing or ambient air curing. That's what I was mentioning. For precursors like fly ash, they'll not be able to react fast on their own. So you need to go for high temperature curing. For slag, you can go with ambient air curing. Swetank is asking, what is the role of C3A in ettringite formation? How does SO3 help in formation of gypsum? No, C3A is absolutely required to form ettringite. In the early cementitious reactions, you've seen that the role of C3A is to interact with the gypsum and lead to formation of ettringite initially. The same thing happens in the long term also. If there's still calcium aluminate available in your system, even in the form of monosulfate, it will react with external sulfate to form ettringite. And external sulfate can come inside and form gypsum when it interacts with calcium hydroxide. Internally, gypsum is already present in the cement, right? But this is consumed during the early stage reactions with C3A.
Sir, silt content by volume, in which IS code mentioned?
Which one?
Silt by volume, silt content.
What do you mean by volume? Silt content is mentioned in IS 383.
Yes, sir.
It talks about, yeah.
This is by weight. Silt content by weight.
Yeah.
I ask for silt content by volume.
Why do you need to know silt content by volume?
So 250 ml take a jar and 150 ml putting sand, and then after water, 1% of NaCl. Vigorously we.
No, I know, but what is the purpose of determining silt content by volume?
Silt. Nothing, sir.
No. See, silt content, you need to minimize it to ensure that your water demand from the aggregate does not go up and you don't start losing your workability fast. Sometimes higher silt content also leads to early age cracking.
Sir, my question was, which IS code is mentioned? I didn't read the IS code. I only
Okay.
read Google. Yeah.
No, if you see, all aggregate properties are written in IS 383. And IS 383 gives reference to the test methods for determining those things by IS 2386. Okay. So IS 383 and IS 2386 are the standards you should refer to.
But
So that will
sir,
talk about all the aggregate methods.
and then by volume, this is not mentioned in IS 383 or through IS 2386. Is not mentioned in a silt content by volume.
No, but silt content by weight is there. No, silt content determination is there.
Okay.
Okay, we've come to the end of the hour. It was a very long discussion today. I'm very happy that so many of you participated. I'm hoping that all of you will do very well. Study well. I know that many of you are working outside. You probably don't get enough time to study, but make sure that you attempt the exam only after studying well. Okay, good luck with everything. And I wish you all the very best.
One last doubt, sir. As you brought out, we are working, sir. So
Yeah.
all these 12 non-graded and 12 graded assignments, is that sufficient, sir, for the exam?
I didn't get you.
So we have attempted 12 graded assignments and 12 non-graded assignments, sir. So almost
Okay.
of 24 assignments into 10 questions. So that means 240 questions.
Right.
So understanding them properly, is that sufficient for the exam, sir?
See, for my suggestion would be that you at least go through the slide contents in the slides at least once more. If not, if you're not able to see the videos, see the slides.
Okay,
Because assignment questions don't cover everything, right? I mean,
sir.
assignment questions are, only providing you one specific set of things, but you probably need to see the slides if you cannot see the videos again. I know it takes a long time to see the videos, but at least read the transcripts or see the slides.
Thank you, sir.
Yeah. Okay. Thank you all very much. Thank you. Thanks for
Thank you,
joining.
Professor.
Bye. Bye.